As we get into logarithmic functions, we'll remember that the exponential and logarithmic functions are inverses of each other. So in red here, we have the graph of y equals 2x, 2 to the x, the exponential function. The inverse would then be reflected across the line y equals x, and we would get that by just reversing the points. The graph of the inverse function, y equals log base 2 of x, is shown in blue. So the same shape. Now, instead of having the y-axis, the x-axis, as a horizontal asymptote, you can see we now have the y-axis as a vertical asymptote. Since the domain of exponential functions is all real numbers, and domains and ranges are for inverse functions are reversed, the range of the logarithmic function then is all real numbers. And the range of the exponential function and the domain of the logarithmic functions will all be the set of all positive numbers. So logarithms can be found for positive numbers only. They can be found for positive numbers only. When we see that as we look at this graph, we have only have the graph on the positive side of the y-axis. X is always positive. But look at these 3 points. Instead of -1, 1a, we have 1a, -1. We have 1, 0, we have a1. We have those 3 points. This is if a is greater than 1. It's increasing and continuous in its entire domain. The domain is the positive numbers from 0 to infinity. The y-axis now becomes a vertical asymptote, and the limit of log base 2 of x as x goes to 0 from the positive side, that's what this little plus means, is negative infinity. You can see it's going down to negative infinity. And the limit of the log base 2 as x goes to infinity is infinity then for the y's. And the graph passes through these 3 points. 1 over a and -1, 1, 0, and a1. You might recognize those as the inverses of the 3 points we use for the exponential functions. When my a is between 0 and 1, we get the decreasing function. We still have the points a1, 1, 0, and 1/2 -1. But it's this decreasing function when a is between 0 and 1. It is continuous also. The limits though, still, as x goes to 0 from the positive side, it goes to now positive infinity because it's going up, and the limit as x goes to infinity goes to now negative infinity because this is a decreasing function. And it passes through those same 3 points. 1 over a, -1, 1, 0, and a1. So the characteristics of a graph of a log function, the points 1 over a, -1, 1, 0, and a1 are on the graph. If a is greater than 1, it's an increasing function shaped like this. If it's less than 0, it's a decreasing function. this way. The y-axis is a vertical asymptote. The domain is positive numbers from 0 to infinity, and the range is all real numbers. The graph of log base 4 of x, well, my points will be 1 over a, so 1 over 4, negative 1, 1, 0, and 4, 1. Graph those 3 points. 1/4, negative 1, 1, 0, and 1, 4. Would also be 2, 8 if you want to go out farther. Or 8, 2 if you want to go out farther. And I didn't say to find the domain and range, but the domain would be the positive numbers from 0 to infinity, and the range will be all real numbers. Let's graph this, and now the base is a fraction, so we know we should have a decreasing function. My points would be 1 over a will be 3, negative 1, 1, 0, and 1/3, 1. 3, negative 1, 1, 0, and 1/3, 1. The domain again will be the positive numbers from 0 to infinity, and the range is from negative, all real numbers from negative infinity to infinity. Do a graph with the translation. We're going to take it up to. My points would be 1/4, negative 1, but move that up to. 1, 0, but move it up to. 4, 4, 1, but move it up to. And now we have our graph. The domain is from 0 to infinity, positive numbers. The range is all real numbers. All we did was move the graph from 2 pages ago up 2 spaces.